the Hammond Sanitary District. They're looking for the Southeast Combined Sewer Overflow with us. I believe behind me is Mark Wilgos, who's the CEO of the Hammond Sanitary District. Jeff Massey, who I don't have an official title for, but I can make something up. Steve is there from Donahue, right? Am I right?
Yes.
And is someone else, is Mike on the phone? Is that Mike's phone? Mike Hickey or not?
It is not my case.
All right, well, Mike's phone is not Mike Hickey. So anyways, we have Steve to give the presentation.
Thank you, Dan. So we are requesting.
Name and.
Oh, I'm sorry.
That's okay.
Steve Stickland with Donahue and Associates, representing Hammond Sanitary District. We are requesting grant funding to start design of a combined sewer overflow treatment facility on the Little Account. This is the approximate location. Zooming in a little bit here, the little blue marker down there. That's near, so Cabela's, just to orient you, Cabela's, this is Indianapolis, right north south, Foreman, and then right over here is Cabela's. So it's across Indianapolis roughly from Cabela's. So here's kind of a close-up aerial view of the area that this will be benefiting. First, the facility will be located approximately here in the center. What it will do is collect combined sewer overflows from these 3 CSO pump stations, which currently discharge a combination of rainwater and raw sewage directly to the Little Calumet River during rainfall events. This creates a number of issues, primarily negatively impacts water quality. Combined sewer overflows are a major impediment to the river reaching its full potential. There are a lot of solids that are discharged annually, along with bacteria and a lot of material that consumes oxygen in the river, which can negatively impact wildlife and fish stocks. So once this project is complete, it will eliminate about 288 acre-feet of CSO discharges per year, about 16% of total annual CSO discharges. Probably most importantly is it will eliminate capture and then send back to the treatment plant about 218 tons of solids that are currently discharged to the river every year. This amounts to about 86 dump trucks. So this should greatly eliminate the dredging and cleaning of the river that currently has to take place due to all these solids. These 3 CSO outfalls are the primary source of pollution and solids into the river. So this will eliminate almost all of that. That's basically it. I mean, there's a lot more technicality to it, but I wanted to try to keep it simple, and I'm happy to answer any questions you might have.
Question about the quantity breakdown of the sediment.
So you'll be combining all 3 of those pump stations to feed one location?
Correct. One pump station has a force main that currently goes through the site. We'll have to do some pumping and pipe work to convey the other 2 pump stations over to the site.
And do you have to go under the expressway for that north pump station?
No, we do not, because there's already the pipe already exists. Right.
Is that empty area right now, or?
Yeah, it's vacant.
Grassland?
It's vacant. Much of it, excuse me, much of it is much of the parcel is designated a wetland. It's a very low quality wetland and the portion of it where we will be building it actually technically is not. So this is a little hard to see, but the area surrounding it's a rather large parcel. It's never really been developed. I think a long time ago there may have been.
Was that one on a fire a few years ago?
Yeah. It's just east of the Starbucks.
Okay, all right, I don't.
Right, so the facility will go right here. There's currently, it's not that area specifically where the facility will go is not a wetland, but most of this is a low quality wetland right now. It's never been developed.
So it's the current sediment accumulation is from where? What sources?
Well, these 3 pump stations that you see on the screen, these are combined sewer overflow pump stations. So in dry weather, all the sanitary sewage is conveyed to the treatment plant. However, when it rains, storm runoff mixes with the sewage and exceeds the capacity of the interceptor sewers that take it to the plant. So, and then that excess wet weather flow, you have a mixture of storm runoff and raw sewage that's discharged directly to the river from these 3 pump stations.
And where's that coming from?
It's primarily urban runoff, residential.
From what communities?
So Walnut and Indianapolis are Hammond. The Kennedy Injector CSO pump station also collects sewage or receives sewage from Griffith and Highland.
Okay, back to your first slide, your 16%. This facility will capture 16% of annual average CSO volumes. And most of the pollutants that are currently discharged to it. The 16% of what total?
Well, 16% of the total, I think there's approximately 500, or I forget the exact number. You have to do the math. The 288 is 16% of, I forget what the denominator is. So I have to do some math. But of the total annual CSO that's discharged in the river, it's 280 divided by 0.1.
And this is in high rain events?
There are CSOs in as little as a quarter inch of rain.
Does that count the Grand Calumet discharge also?
No,
That total number?
no. This is just from these 3 pump stations.
Okay.
Up in Little Cal.
But they're only 16% of the CSO of the entire city of Hammond?
This is, no, this is what this is saying is that this project will capture 16% of the total CSO from those 3 stations on Little Cal.
Okay.
Not system water.
So they're gonna spend 80 million bucks to only eliminate 16%?
Well, this is primarily a water quality project. It's to get pollutants out of the river, which are a huge impediment, to
You're
develop.
only getting rid of 16%. What about the other 84? You don't care?
Well, no, the water is treated. So what this facility is gonna do is, what's going on now is basically a mixture of rock. Almost all of the pollutants will be captured and sent back to the treatment plant. So what will be discharged from this facility, the remaining 84% will be discharged, but it will be clean. It will go through these filters and it will be disinfected.
So it's a good thing you explained that, because it doesn't come across that way with a slide. Yeah.
That's not clear. That's not clear in your description on the bottom of page 1 either.
Yeah, perhaps I oversimplified. The earlier iterations of this presentation,
So we're not dumping 84% in the river, is what you're saying?
the 84% of the flow is going, but it's clean. Almost all of the pollutants are captured and concentrated, sent back to the treatment plant for final removal and disposal.
And 16% represents the amount that is not clean. 84% is clean already, and 16%, which is close to what you just said, the majority of what's being captured is actually going to be treated.
What the 16% is the volume that's actually captured and reduced. So almost all of the pollutants are captured and removed.
Which consists of 16%.
The 16% is the volume that is removed. So there's some storage in this facility, and that volume is a flow equalization tank that will capture the first flush. And that amounts to about, so 60% of the volume will be captured and almost 100% of the pollutants will be captured. I'm sorry, that's not clear. I have other slides that might help clarify this for you. I kind of put them in the supplemental. But here, let me show you. This might make it a little more clear. So this is what the facility, or an example of what one of these filters will look like. So there's the dirty combined sewage coming in from the left. The 16, and then the solids are captured in this treatment facility and concentrated and then sent back to the treatment plant for final removal and disposal. And about 60% of the volume that currently goes to the river will be captured and sent back to the plant. The remaining 84% will go to the river, but that will be cleaned. That make sense?
Yes.
Sure.
So when we get to how much of the pollutants are captured, it's much more than that. We will be capturing about 90% of total suspended solids and almost all of the bacteria that currently goes in there.
I think that graphic probably represents a better picture of what's going on.
So you get,
Go back to the other graphic.
can you go back to that, please?
The other graphic. The graphic you showed, no.
Sorry.
With the table, the one with the table
Oh,
on
the
it.
table, I'm sorry.
I think that tells a better picture of what's going on.
So are these, I'm assuming these are real numbers, the number of existing events, future, you can forecast a future based on,
These are what we call typical year values based on a collection, a model that was developed in the collection system.
now, is there a place that you guys have, in reference that you've actually done this type of project at, or that has been done in the area? That use this same filtration process to actually abate those CSO contaminants?
I'll jump in here for a second. My name's Marty Wilgus. I'm the CEO of the Hammond Sanitary District. I want to clarify a couple of things. First of all, this project not only affects the water coming from the south of Hammond, but everything in the south of Hammond collects also Highland and Griffith. So we solve both Highland and Griffith's problem right now, including Hammond's problem. That's what this whole project's about. I want to just get that clarified. To answer your question, the new technology that we're talking about, the CMDS, has been used for several years. I call it new technology because both the state of Indiana and the US EPA have agreed that the way we want to apply this system to the project that we're talking about at the Little Calumet River, as the water's coming in from the south, they believe it's going to work. And we are the first that are using this technology in this manner. This technology is currently being used inside wastewater treatment plants to do basically the same thing, but with inside the wastewater treatment plant. We're taking and building it outside the wastewater treatment plant on the base of the Little Calumet River. That's the big difference. And so we actually had to do a test model of this system at the plant, bringing in wastewater combined with stormwater for both Indiana and the US EPA. They came, they saw our test for about 3 months and agreed that they accept this technology.
Was there documentation that followed up after the 3-month study?
Yes, yes.
What did they initially want?
Well, they wanted more basins. So we have a 30 million gallon basin right now, right across the street from the Hammond Sanitary plant. It's not pretty. And I totally believe that we have a responsibility to all the communities. It would make no sense. So I challenged the engineers that I said, I want no more basins. There's got to be something out there with new technology. And after beating up our engineers for about 1.5 years, and Jeff will tell you that's maybe even longer, they came up and they said, hey, we found something we think will work. The problem was it wasn't being used the way we wanted to use it at the income of the waste and stormwater. It was being used inside a plant. So we actually had to do the demonstration. I actually paid the company that designs this system to bring one of the units to the plant, set it up, hook it up with direct wastewater mixed with stormwater, so that both, like I said, the state of Indiana and the federal government got a chance to come down and see it work. And I'll let Jeff talk just briefly about the results that came out of this project.
Hi, I'm Jeff Massey, Superintendent of Wastewater Treatment for the Hammond Sanitary District. We did what was called a pilot test of one of these treatment systems, and we had it set up at the district, and we were using mainly raw sewage with a little bit of storm water to see how these systems work. And we were able to achieve near effluent quality through these systems with little hassle whatsoever, little work with it whatsoever. Definitely secondary quality, but nearly as well as the tertiary quality what we're able to get from our whole treatment system. We were pretty pleased with the way everything worked, and we were hitting it with waste that's far worse than what we'll ever see on any of these CSOs, and it worked. It was fantastic in how it works. These systems appear in other places, and as Marty said, typically at wastewater treatment plants in Rushville, Indiana, they have a large system like this that takes CSO water at the plant and brings it through the system and then brings it back to the same outfall as the wastewater treatment plant. This one's gonna be a little bit different, that it's freestanding, but it's a proven technology. It works well. It will do wonders for the water quality at Little Cal for these stations, removing a lot of the solids debris and actually shutting off 2 of the 3 discharges that are currently discharging into the river now.
Will the water go to the plant or just gonna go right at?
About
it's gonna be
16%
treated right there.
84% of the water will be treated and sent out right to the river. 16% is these filters collect all of the solids. They'll collect that waste, send it back and send it to the plant for further treatment and disposal of the solids. So all of those solids that would normally ended up in the river that you at Kennedy Avenue where you guys had to go clean it out, that's never going to make the river. It's all going to come back to the treatment plant by Columbia Avenue, and we will treat it there and take care of it there.
So Jeff, who's the company that actually helped you guys with the proof of concept here?
I'm sorry?
Who is the company that has the filtration technology that actually?
A company called Aqua Aerobics is the one that we're looking at. And I don't know if there's another manufacturer or not. There might be.
Can you repeat that again?
The company's name is Aqua Aerobics.
Okay, thank you. And then was there a target micron filtration that the US EPA required?
This is one of the possibilities for treatment of the water that we looked at. This is the most effective and most easily used and the most cost effective. I mean, there's other ways you could do things that required a lot of chemicals and a lot of sedimentation and things. And this was by far the safest and easiest way to do it. We didn't want to get into an area like this and have to have a lot of harsh chemicals and a lot of treatment that wasn't easily used. This system is pretty self-obtained, pretty self-contained, pretty self-sufficient. It does what it needs to do. It's a simple filter system. Doesn't require a lot of, specialized chemicals or something with it. So it works fairly well all on its own. And that's what the big advantage to this system is.
I go on there.
I think, excuse me, to answer your question, I think you would inquire about the pore size on the filters. Is that correct?
That's correct.
Yeah, so there are a variety of different cloth media, different types of cloth media. The one that we'll likely use in this application has a pore size of about 0.14 micron.
Okay. And I'm assuming that meets the US requirements.
Well, there's not a requirement, pore size requirement for this particular application. Ultimately, the requirement is that the river meet water quality standards.
Okay.
And this will enable that.
Okay.
So you guys did a pilot and this is an expansion on top of that.
Right, just to give you an idea of the size of this, it's about the size of a football field, all enclosed in a building. It'll be set and designed so that it mixes in with everything that's already there, so it doesn't stick out as a treatment facility within. It's totally, almost entirely unmanned. And there are several of these pieces of equipment. I'm not sure what the total number is. What do we know what the total number is?
Well, we estimate there will be 7 of these operating in parallel.
So 7 of these operating in parallel inside this building. So we wanted to make sure that we picked the right location with the ability to get our pipeline into where we already are located, and to be able to accommodate both of our customer communities, Highland and Griffith, to make it easy for them to get to us. So right now you have, everybody dumping into the river when we have to. We're permitted by law. And sanitary is permitted by law. And so this will help eliminate a lot of discharges into the Little Cal, without a doubt. It's a very expensive project, and that's why we're asking this commission for $1 million.
So does anyone have a number of the?
Initially, Marty?
You know, I'm never, I'm never one to tell you something and then come back 4 months later and say, you know what, I missed something.
This is just for the design.
That is correct.
Will you be coming back and asking for money for the final?
You know, I'm being honest with you,
Uh-huh.
and I want to answer the question as directly as I can. You know, I'm always asked about, well, you know, you have 4 customer communities, three customer communities, I should say, Whiting, Highland, and Griffith.
Right.
We treat all of Hammond and all of Munster. Munster's our partner in the district. And everybody says, well, you know, how are you going to pay for all this? Well, part of this is going to be a part of meeting some of our long-term control plan to the tune of about $250 million over the next 25 years. That's what the district and the federal government came to an agreement to. And everybody says, well, how are you going to pay for that? Well, the federal government says, you'll find a way to pay for that. You're bound by the agreement, right? So what I try to do is move in a plan that addresses not only our needs at the plant for basic operation and doing all the things we have, but to also do these type of projects. Because these type of projects, because of the tax caps, are all rate-based. That's how they get funded, rate-based, not by tax base anymore. So that puts a bigger burden on the district because we have a responsibility to not only Hammond, Munster, but our 3 customer communities. So to answer your question, and I get this asked a lot of me, they said, well, all of our chlorine costs have gone up 5 times.
Right.
That's just one of the things that we use at the plant. All of our piping, as I'm sure everybody else here is experiencing, has quadrupled. So what I look at is maintaining a level stream moving forward. I already did phase 1 on a property that we're looking to acquire. Already getting a number set for engineering, around 4 million, and to be able to keep moving forward slowly. I mean, it was just like the property that we had bought, if you remember. I came to the commission several years ago.
Right.
The Linden property, the west side of Linden in Hammond off of Columbia Avenue. We acquired all those homes because of what I wanted to do was put in a catch basin there of about 1 million gallons that would help us buy time in heavy storm events. That would have been all stormwater, would have not been mixed wastewater. Technology changed. And so I'm not one to move with a project and build more basins when we have the ability to use new technology that makes sense. It's a little more costly, but at the end of the day, it does a way better job. So to answer your question, will I be coming back in 3-4 years? I really don't have an answer to that. It depends on the crazy environment that we're in and what may change. I have no idea.
Gotcha. Fair enough. Anybody else?
So Marty, can you or Scott just give a timeline or base and status of where you guys are on this project?
Well, here's an approximate schedule. So we're pretty far along in the land acquisition process. We've completed the phase 1 environmental site assessment. Didn't find any liens or anything that should preclude the project from proceeding there. So in that process, we anticipate completing the preliminary design. We're near the end of this year, although that may have slipped a little bit. We need to complete an asset management plan if we're going to go with SRF funding. But we anticipate a final design regardless being completed at the end of March of 2024. And then hopefully have that built by the end of 2026.
Dave?
Yes, Marty, first of all, I want to compliment you. It's a very impressive presentation that you're making, especially with the new technology. I'm all for new technology. But considering this way this river is and how important it is to the people of Northwest Indiana, I just wanted to know, did you consider a fail-safe plan in the event of power failure or equipment failure that may occur in your design? I'd like to know if you would take that into consideration before we go forward.
Well, actually, we have because of the number of units we're going to have.
Right.
So the possibility of half or more breaking down at once, or just not doesn't make it's just not technically, not my scale to think. The filters themselves are always backwashed after an event. So and then we'll have a maintenance person there every day to check on the facility. You have to remember that with the amount of money that's being spent on this project, it's only used in heavy rainfall to prevent the overflows. So it's not something that's running every day. So the idea of the longevity that we can get out of this project even excites me more, because it does two things. It solves the immediate problem of dumping into the river wastewater. It helps our two customer communities in the south, specifically Highland and Griffin. And at the end of the day, it's good for everybody in the environment.
Eric? I guess just to add on that, I don't want to minimize the fact that it's not running every day, because if I read the graph correctly, or the chart correctly, you used a model which said that 28 events. So that's essentially in an annual year. Think about a month being 30 days, one discharge from 3 different combined sewer overflows for an entire month each day. That seems like a lot. Even though it's not running every day, that seems like better water quality in the long run.
Well, and you're right. I mean, if you think about it, the wastewater, Hammond wastewater treatment plant's rated for 48 million. And we're handling all these communities. So this will help us, because not 100% of all of what's coming across the line, including South Hammond, is coming to the wastewater treatment plant. So that's a big plus. And as I said, several years ago, we built that 30 million gallon basin that is technically a big hole in the ground with a liner that was $55 million. So we have some backup. And the good thing about this project, in my mind, is the fact that it meets a lot of the criteria that not only the state of Indiana has set out for us, but also the federal government. And I agree. If you look at, I'm born and raised here in Hammond, Indiana. And I remember as a child going over the Grand Calumet Avenue Bridge, and all you would see is crossbones and skeletons. Don't touch the water, don't. And you would see all the garbage. You couldn't even see. It was all murky and nasty. I love giving tours at the plant because, one, I like the residents to see what we do. You can only imagine what comes into the plant, which if we don't treat, goes into the little Cal. And when we're at the end of the line of treatment, which is all bacterial type of treatment that we do, live organism, at the end of the day, our fluid going out back into the river, back into Lake Michigan, it's so clean, wildlife has returned in abundance, not only to the river, but on the 28 acres that we have on the east side of Columbia Avenue, the main part of the plant. Wildlife of every particular kind. We know there are bald eagles down towards Gary on the Little Cow. I'd like to see them come farther west. This will help without a doubt. And I know it's a lot of money. I know asking anybody for $1 million is a lot of money. I wanted to make sure I was here tonight. And I told Mayor McDermott, I said, you have Mayor's Night Out tonight. I am not going to be there. I'm going to be at this meeting because I think it's very, very important. It's a big project for us. And I wanted to make sure you had a chance to hear from my team and also directly from me.
We appreciate that.
Thank you.
Yep. Thank you guys very much.
Thank you.
Thank you.